All right, so for today, we're going to be working off a whiteboard instead of a book because the book's explanations for these lessons are a little confusing. So today, we're working with similar shapes, congruent shapes. So we've learned a little bit about congruent. We'll talk a little bit more about similar shapes. We're also going to be working at solving, or how to determine if they're congruent or similar. Solving for a side if they're similar shapes, and we don't know one side on the other shape. And perimeter and area of triangles and rectangles. So some of it hopefully is a review, but you'll be learning a few new things. So we're going to start with congruent shapes. So congruent means that shapes, that's upside down for you, isn't it? Congruent means that shapes have the same size sides and angles. So an example of this, let's pick a triangle. Let's say I have a triangle right here, and that's a 90-degree angle. Let's say I have 3, 4, and 5. That's my lengths right here. 3, 4, and 5. The same triangle right here, imagine this is the same exact size, all the angles, everything's the same. 3, 4, 5. These shapes are congruent. 3, 4, and 5. I know you can see it at first. So 3, 4, and 5. These are congruent shapes. Everything is the same. Now, if I drew this shape right here, 3, 4, 5, and I have this shape right here, even though it isn't oriented the same, it's changed a little bit, all these sides are still the same. The corresponding sides now are these. So think about how we did it last time. These are still corresponding sides. This is still congruent. It just had a reflection. So if it transforms in some way, but it has the same corresponding sides, are all the same, and the angles are all the same still, it's still congruent. So it can go through transformation and orient differently, but it can still be congruent because even though that happened. As long as the sides match, so 3 and 3, 4 and 4, 5 and 5, they are congruent. Hopefully that makes sense. And so hopefully that's a little bit of review. We kind of talked about congruence a little bit. So let's move on to similar shapes. Oh. So these are shapes that have all the same angles. All their angles are the same in E. All their corresponding angles. I should say corresponding angles. They don't have the same angle all the way through. All the corresponding angles are equal, and all of their sides are scaled. All their corresponding sides. Sorry, I keep forgetting to put corresponding. Corresponding sides are scaled. So what that means is if I have a side, I'll actually visualize this for you. Let's say I have this triangle over here, and I have 6, 8, 10. 6, 8, and 10. Now I have a smaller triangle. Imagine all these angles are the same. and this are 4, 5, and 3. Well, what I'm saying when these are scaled, these are similar triangles. What I'm saying when this is scaled is I'm saying I can divide this number by 2 and get a 4, divide this number by 2, get a 3, divide this number by 2 and get a 5. I can do the same operation on all of these numbers and get these numbers as long as it's division or multiplication. When it's scaled, it can only be division and multiplication. It cannot be subtraction or addition. That is not similar. So I can go from this one, multiply this side by 2, get my 8, multiply this side by 3, get my 6, and multiply this side by 2, or multiply everything by 2, and get all these numbers. So 5 times 2, 10. 4 times 2, 8. 3 times 6, or 3 times 2, 6. So, depending on which way, my scale factor from going from this triangle to this triangle is 1/2, or going from this triangle to this triangle is 2. So, all I want you to really think about is, I have to multiply or divide by the same number to get every single number on the other triangle. The same number. So divide by 2, I'm going to get all of these numbers from these corresponding numbers. So 8 corresponds to 4, divide by 2 to get 4, divide by 2 to get 5, divide by 2 to get 3. I'll show you another example. Let's do 15, 12, and 8. 9. I'm going to do 9. 15, 12, and 9. And I go to this triangle, which is same angles, because if it's going to do this, if it's just similar, they'll have the same angles. I'm not going to have you worry about looking at angles though. 3, 4, and 5. I like those numbers. So, I'm doing the 3, 4, and 5. If I'm going to look at these, I can see that this is divided by 3, this is divided by 3, and this is divided by 3. I'm going to get all these numbers. 15 divided by 3 is 5. 12 divided by 3 is 4. 9 divided by 3 is 3. So I don't care which side you go to, but I want you to think 15 times or divided by what equals 5. Figure out what that is. What number equals 5? Alright, 3, and that'll give me 5. So, I know this is 3 now. I want to try this same operation with another one. Just replace 15 with one of these. 12. Divide by 3 equals 4. Is that true? Yes. So let's try it with the last one. 9. 9. All these numbers are going to go straight across from here. Divided or multiplication, whatever one gets you to your value over here. Divided by 3, the number you found, your question mark number, equals whatever corresponding number you have here. So 9 corresponded with 3. 9 divided by 3, is that 3? Yes. So these numbers go here. These go here. Whatever your scale factor is that you found, you had to think about this, goes here. And then these numbers are up here. So this number will stay the same. These numbers will change throughout this triangle. And the corresponding numbers on this triangle will go on this side. And you have to say if it's true. It has to be true for all of them for it to be similar. Hopefully that makes sense. If it doesn't, email me a question. We can go through that. Now, when we're solving for an unknown value, this is the next part. If I have a triangle and we're solving for an unknown value, so I'm going to give us some numbers. 6, 9, and 15. And I have another triangle, and I know this is 3, I don't want 3. Hang on. 2, 3, and I don't know what this one is, so I'm going to have an x. So this is the one we're solving for, x. In order to solve for this, I have to do kind of like what I did before. Take a number from here, and now am I dividing or multiplying? My number gets smaller, so I'm dividing. By what number equals, what's my corresponding side to 9? Well, that's 3. Corresponding, because they're in the same position on this triangle. So I have 3. So 9 divided by what number equals 3? 9 divided by 3 equals 3. So this is my scale factor now. Now I know these triangles are similar. It's going to tell you in the directions that these triangles are similar. So now that I have my scale factor, I don't even have to think about the other numbers. I can go straight to this number here. 15 divided by, because I know these are corresponding, divided by my scale factor, which I just found, 3, equals x, my corresponding number. Same position on this triangle. Scale factor stays the same throughout. 15 divided by 3 is 5, so x equals 5. That's how we'll do these. Now, let's say I have a rectangle. And it only gives me 2 sides. So I have 10 and 4. And then I have over here a little bigger rectangle, 8 and 20. So I want you to think about rectangles. Whatever this side is here, this side is also. So we can actually fill, if it only gives you 2 sides, you could just fill out the rest. This is also going to be 10. It matches the opposite side, 8, 20, because that's just how rectangles work. So I see you can't see that now, I'm looking. That's just how rectangles work. So these sides are going to match. Let's see if I can. All right, so I'm going to draw this one down here actually. 4 and 10. I know that these are going to match. 4 and 10. So, yeah, my bad. I'm going to give you different ones. I didn't mean to give you all the sides. So, we'll do 12 by 3. And then I'm going to have a a 4 by x. And I don't know what this x is. So I'm going to look at these. I can see that these already match. I don't need to worry about these other sides, even though I know they're going to be 12 and 3 and 4 and x, because they're just going to match. But I don't have to worry about that, because I already have my corresponding sides. I only need one corresponding side to do this. So I'm going to have my 12 divided by, because it gets smaller, by what number, we don't know what number it is, equals my corresponding side, 4. So what number, 12 divided by what number equals 4? 12 divided by 3 equals 4. So 3 is my scale factor. I can use that now to do my new number. So all of these are going to go on the left. 3 divided by 3 equals the smaller triangle or the new triangle, whatever one you have, your new triangle, which was x. So x, 3 divided by 3 is 1. So 1 equals x, or x equals 1. That is how you solve for similar triangles. They will tell you it's similar. Hopefully that makes sense to you. I'm going to go through area and perimeter pretty quickly because I feel like it's a little bit of review. You can email me if you have questions. I can go through it a little better. So for a triangle, perimeter is the sum of all sides. So if I have 3, 5, and 4, my perimeter is just adding all these sides up. So 3 plus 4 plus 4 plus 5, which is 7 plus 5 is 12. 5 plus 4 is 9, plus that 3 is 12. If I have a rectangle, let's say we have 5, 4, 5, 4. Sum of all the sides, 5 plus 5 plus 4 plus 4 is 10, 18. 10 plus 8 is 18. I'm just adding all the sides together. Now make sure, if it does give you just 2 sides in a rectangle, you just fill in those extra sides because they just match the opposite side, 5 and 4, and then you can add those together. Make sure you're adding all the sides. Now, area. Area is a little different. For a triangle, area is 1/2 base times height. This is your formula right here. So area equals 1/2 base times height. This is the formula you're going to use. So for a triangle, if I have something like this, and I'll just do our normal 3, 4, 5. My base is this 3, it's the bottom, the one that touches that vertical line. Your vertical line is your height, your base is the bottom. So 3, that's my base. I have 1/2 base times my height of 4, height is 4, and that gives me 12, 3 times 4 is 12, times 1/2 is 6. So 6 would be my answer for this area. Now let's say I have a triangle like this. 6, 3, 9. Something like that. Height, vertical line, 3. It has to be vertical. If you see something like this, which I don't think I'm going to show you in this worksheet that you have coming up, your height isn't this line right here, because that's not a vertical line. Your height is this line right here, this dotted line. Your height to the very top of the shape. But I don't want you to worry about that too much because we're not going to go over that too much in my worksheet. Focus on this. Height is the vertical line. So 3. My base is the bottom. 6. 1/2 base times height. 1/2 times 6 is 3 times 3 is 9. So 9 is my area. Now, area of a rectangle is just length times width. Length times width. Or written in formula notation, area is length times width. So if I have a rectangle, 8, 10, 10, 8, we'll do that. 10, 8, I do 10 times 8. Find my length and my width, multiply them, and I get 80. Just focus on remembering those formulas. Triangle like or rectangle like this, length is 5, width is 11. I'm going to get 5 times 11, length times width equals my area, which is 55. So hopefully that's not too bad. A little bit of review, hopefully. That's it for this lesson. Let me know if you have any questions. I'll try to answer them the best I can and as soon as I can. Continue to email me. You can slow this or go back at any point in this video to relearn something. If something doesn't make sense, just email it to me. Hopefully this will help you for this worksheet. Yeah, just email me any questions you have. I'll be happy to try and answer them. If you don't get a hold of me right away, if I don't answer, just make sure to email me again because I might have just missed it or something. So hopefully, if I don't respond in 3 hours, I probably missed it. Just email me again and I'll try to get back to you. All right, thanks. I hope you have a good rest of the day.